Hello viewers, in this video lecture, today we are going to talk about the massive open online course on emerging technologies and renewable energy sources. Name of the module is Energy Audit Fundamentals, in which I am going to discuss about lecture on the motor performance factors. In the last video, we have learnt about motor and its efficiency. So, viewers, here are the important topics which will be discussed in this video. Basics of motor performance, major performance factors of electric motors, electric motor other performance factors, factor affecting performance of motors, rewinding of motor, steps involved in the process of rewinding of a motor, and purpose of rewinding of motor, motor replacement issues. Now, let us discuss in detail basics of motor performance. The basics of electrical motor performance involve understanding the key parameters and characteristics that determine how an electric motor operates and performs. Electric motors are devices that convert electrical energy into mechanical energy, and they are widely used in various applications ranging from household appliances to industrial machines. Here are some fundamental aspects of electric motor performance. Understanding these basics of electric motor performance can help in selecting the right motors for a specific application, optimizing energy usage and ensuring reliable and efficient motor operations. Major performance factors of electric motor motor performance depends on three elements such as voltage across the terminals, resistance across the terminals and magnetic force. Various factors that affect these elements and change motor performance will be discussed here by the way of giving some specific examples. Electric motor other performance factors. Electric motor performance can be evaluated based on several key factors that determine its efficiency, effectiveness and overall functionality. The performance factors of an electrical motor include power output, torque, speed, efficiency, power factor, stating torque, overload capacity, temperature rise, inertia, noise and vibration, reliability and durability, size and weight, control and feedbacks. It is important to note that different motor types, for example, DC motors, AC induction motors, brushless motors, etc., may exhibit variations in their performance factors. When selecting an electrical motor for a specific application, it is crucial to consider these performance factors to ensure the motor meets the requirements and provides optimal performance. Factors affecting performance of motor. There are several factors can significantly impact the performance of an electric motor. Understanding these factors is crucial for selecting the right motor for a specific application and optimizing its efficiency and reliability. Some of the key factors affecting motor performance include motor type and design. Different types of motors, for example, DC, AC, induction, synchronizers, etc., have distinct design characteristics that influence their efficiency, speed, torque and overall performance. Second, motor size and power rating. The physical size and power ratings of the motor determine its capacity to handle loads and the amount of mechanical work it can produce. Third is load characteristics. The type of load connected to the motor, constant torque, variable torque, constant speed, etc. affects its performance and efficiency. Fourth is operating voltage and frequency. The motor's performance is influenced by the voltage and frequency of the power supply it receives. Fifth is operating speed. The speed at which the motor operates affects its efficiency and power consumption. Different motors have specific speed torque characteristics. Sixth is operating temperature. The motor's performance can be affected by ambient temperature and the ability of its cooling system to dissipate heat. Seventh is efficiency and power factor. These parameters indicate how effectively the motor converts electrical energy into useful mechanical work and how efficiently it uses the supplied power. Eighth, starting and stopping. The method used for motor starting and stopping, for example, direct online starting, soft starters, variable frequencies, drives can impact its efficiency and mechanical stress. Ninth is motor control. The type of motor control used, for example, open loop, closed loop, vector control. फिर से बोल रही हूँ वाला. Ninth, motor control. The types of motor control used, for example, open loop, closed loop, vector control, affects the motor's ability to maintain speed and torque accuracy. 10th is load torque variations. A motor performance can be influenced by variation in the load torque during operation. 11th is mechanical and electrical losses. These include copper losses, iron losses and frictional losses which can affect motor efficiency. 12th is insulation and winding. The quality of insulation and winding design plays a role in a motor's reliability and ability to handle varying loads and conditions. 13th is operating environment factors such as humidity, dust and corrosive substances in the operating environment can impact motor performance and lifespan. 14th, maintenance and service. Regular maintenance and timely repairs or replacement can help maintain the motor's performance and extend its operational life. By considering these factors and selecting the appropriate motor for the use of specific applications, users can achieve optimal motor performance, efficiency and reliability while minimizing energy consumption and operating costs. Rewinding of motor. Rewinding of motor refers to the process of replacing or repairing the electrical winding in the stator or rotor of the motor. Over time, due to various factors like wear and tear, overheating, electrical faults or damage, the motor windings may deteriorate or fail, leading to decreased performance or motor failure. Rewinding is a common method to restore motor's functionality and efficiency without the need to replace the entire motor. Remember, these motors are not simple pieces of equipment. This rewinding process needs to be done to a very precise standard of quality to ensure maximum results, especially if the motors need to be operating at a very specific standard. By stripping these wires away, they can be replaced with a fresh set of windings, restoring the motor to full efficiency. The wires need to be rewound through a stator are reinstalled alongside any other replaced components, getting the motor back to its original state. While This might just seem like a simple repair job. Motor winding is a very specific process that can take some experience to do correctly. Winding a motor incorrectly could potentially lead to problems further down the line, including issues with the motor not functioning as intended. Steps involved in the process of rewinding a motor. The process of rewinding a motor typically involves the following steps. First is motor inspection. The motor is first thoroughly inspected to identify the extent of damage and the specific areas that require rewindings. This includes examining the condition of the windings, insulation, core and bearing. Second is disassembly. The motor is disassembled to access the stator or rotor windings. This may involve removing the end bells, rotors and any other components necessary to access the winding. Third is removal of old windings. The damaged or faulty windings are carefully removed from the motor. This process may involve cutting, striping and unwinding the old copper or aluminum wires. Fourth is cleaning and preparation. The stator or rotor core and the slots are cleaned and prepared for the new installation of windings. Any remnants of old insulation are removed and the core is inspected for any signs of damage. Fifth is winding installation. New copper or aluminum wires are carefully wound into the stator or rotor slots following the specific winding patterns required for the motor's design and its application. Sixth is insulation and varnish. Proper insulation materials are applied between the windings to prevent short circuit and improve the motor's dielectric strength. The windings may be dipped or coated with the insulating varnish for added protection. Seventh step is reassembly. After the winding process is complete, the motor is reassembled and all the components are put back into its proper place. Eighth process is testing. When it is rewounded, eighth process is testing. When the motor is assembled again, the rewound motor is subjected to comprehensive testing to ensure that it meets the required specification and performance parameters. This includes tests for insulation resistance, resistance measurement and full load testing. Rewinding a motor requires skilled technicians with knowledge of motor design, winding patterns and insulation materials. Improper rewinding can lead to reduced motor efficiency, increased energy consumption or even motor failure. Therefore, it is crucial to have the motor rewound by a qualified and experienced motor repair service provider. In some cases, especially for smaller or less complex motors, it might be more cost effective to replace the motor rather than rewinding it. Now, let us understand the purpose of rewinding of a motor. Rewinding of a motor is typically necessary due to various reasons, mainly related to the degradation or damage of the motor's electrical windings. The primary reason for rewinding a motor include: first, winding failure. The windings in the motor can experience electrical faults such as short circuits, open circuit or insulation breakdown. These faults can be caused by excessive heat, voltage spikes, overloading or aging of the insulation. Rewinding replaces the faulty windings, restoring the motor's electrical integrity. Second is winding deterioration. Over time, the insulation on the motor windings can degrade due to factors like heat, moisture and mechanical stress. As the insulation weakens, the motor electrical performance may suffer, leading to reduced efficiency and reliability. Rewinding involves replacing the deteriorated windings with new properly insulated ones. Third is burned windings. If a motor experiences severe overheating, the windings can get burned or damaged. This can occur due to prolonged overheating, voltage imbalances or restricted ventilation. Rewinding is necessary to replace the damaged windings and restore the motor's operation. Fourth is physical damage. Physical impacts or mechanical stresses can damage the motor windings, resulting in electrical faults or reduced performance. Rewinding can address the damage by installing new windings. Fifth, upgrading efficiency. In some cases, older motors may have lower efficiency rating compared to modern high efficiency motors. Rewinding can be done with improved winding configurations and materials to enhance the motor efficiency. Sixth is modification of new applications. Motors may need to be rewound when they are repurposed for different applications or operating conditions. Rewinding allows customization of the motor to suit the specific requirement of the new application. Seventh is economic considerations. Rewinding can be cost-effective alternative to motor replacement, especially for larger or specialized motors. It eliminates the need for purchasing a new motor and reduces downtime during the replacement processes. It is important to note that not all the motors are suitable candidates for rewinding. The decision to rewind a motor depends on factors like motor size, design, condition and the extent of damage. In some cases, motor replacement may be a more viable option, especially for smaller motors or when rewinding is not cost effective or technically feasible. Proper maintenance and operating conditions can help prolong the life of a motor and reduce the likelihood of extensive rewinding needs. Now, motor replacement issue. Motor replacement can be a complex process and several issues may arise during or after the replacement. It is essential to address these issues to ensure the successful installation and operation of the new motor. Some common motors replacement issue include compatibility. Ensuring that the new motor is compatible with the application and system requirements is crucial. The replacement motor should have the same or similar specification including power rating, voltage, speed torque, mounting and shaft design. Second is mounting and alignment. Proper mounting the new motor and aligning it with the driven equipment is crucial for smooth operation and to prevent premature wear or damage. Third is wiring and connections. Correctly connections the new motor to electrical system is essential to avoid issues like incorrect phasing, voltage imbalance or overheating. Fourth is enclosure rating. The new motor should have the appropriate enclosure rating to withstand the environmental conditions in the application area. Using a motor with an inadequate enclosure could lead to a premature failure. Fifth is efficiency and performance. While replacing an older motor with a newer, higher efficiency motor can be beneficial in terms of energy savings. it may be required to adjust to the motor control system to drive the optimized performance. Sixth is motor protection, ensuring that the new motor has proper overload protection and thermal sensors is essential for preventing damage due to overcurrent or overheating. Seventh is motor starting and stopping. If the replacement motor requires different starting or stopping method, adjustments may be necessary to ensure smooth operation and prevent excessive wear. Eighth is dynamic loads. In the application with dynamic loads or varying torque requirements, the new motor should be capable of handling these conditions to prevent issues like motor stalling or overheating. Ninth, interference with other systems. The replacement motor should not interfere with other equipment or systems in the vicinity. Clearance, spacing and proper insulation should be considered during the installation. 10th, motor testing and commissioning. After motor replacement, throughout testing and commissioning are necessary to verify that the motor operates as expected and meets the application requirements. 11th, warranty and service, ensuring that the replacement motors comes with a warranty and is backed by reliable service and support is essential for long term reliability and peace of mind. To avoid potential motor replacement issue, it is advisable to consult with our motor manufacturers, suppliers or experienced motor technicians during the selection and installation process. Main points consider during motor replacement. Motor replacement is critical task that requires attention to detail and proper planning to ensure a successful outcomes. Here are some essential points to keep in mind during motor replacement. First is motor specification. Verify that the replacement motor specifications match the requirements of the application, including voltage, frequency, horsepower, speed, frame size and mounting dimensions. Second is application compatibility. Ensure that the replacement motor is suitable for the specific applications and can handle the intended load and duty cycle. Third is efficiency and energy savings. Consider using a high efficiency motor to potentially reduce energy consumption and operating cost over the motor's lifespan. Fourth, motor type. Choose the appropriate motor type based on the application needs and operational characteristics. Fifth, shaft compatibility. Ensure that the replacement motor's shaft diameter and length are compatible with the driven equipment and any coupling used. Sixth, motor enclosure. Select the right motor enclosure type suitable for the operating environment. Seventh, mounting and frame size. Verify that the replacement motor mounting and frame sizes match the original motor to ensure proper fit and alignment. Eighth is motor cooling. Consider the cooling method for the replacement motor, whether it is air cooled or liquid cooled, depending on the application requirements. Ninth, motor winding and connections. Ensure that the replacement motor's wiring and connections are compatible with the existing electrical system. 10th, safety compliance. Verify that the replacement motors meet all safety and regularity standards for the specific application and location. 11th is testing and commissioning. After installation, perform throughout testing and commissioning to check the motor performance and verify that it operates correctly. 12th, professional installation. If necessary, hire a qualified electrician or motor technician to install the replacement motor properly. 13th is disposal of old motor. Ensure that the old motor is disposed of following local regulations and environmental guidelines. 14th is training and documentation. Provide a training to relevant personnel about the operation, maintenance and safety considerations for the new motor. 15th, downtime planning. Plan the motor replacement to minimize downtime and avoid disruptions to the application. 16th, motor protection. Consider adding motor protection devices such as overload relays, thermal sensors, etc. 17th, alignment and balancing. If the motor is connected to a rotating equipment, ensure proper alignment and balancing. 18th, warranty and support. Check the warranty terms and support. By keeping these points in mind, we can ensure a smooth and successful motor replacement which will lead to optimal performance, improved efficiency and reduced risks of premature failure. Motor replacement plays a crucial role in motor efficiency. If motor is installed properly, the efficiency of the motor will be efficient. Now, let us summarize today's video session. Today, we have learned about basics of motor performance in detail, and we have also discussed about major performance factors of electric motors. Electric motors, other than performance factors affecting performance of the motor, rewinding of the motor, steps involved in the process of rewinding of a motor, purpose of rewinding of the motor, motor replacement issues. So, I suppose you must have had a good learning experiences watching this video. So, keep watching and enjoy learning. Thank you very much.